Имате различни около някакви технически проблеми, ще почнем след 2-3 минути. All right, we're good to go. Today, again, it will be entirely in English. We have some guests. So, yeah. So, first of all, thank you, staff, for hosting us in your new building. It's very cool, and yeah, good luck with the new location, even though it's a bit tricky to get here, but yeah, your choice. The team, I think everybody knows everybody, right? But the question, who is here for first time? All right. So, open question: how do you get it that we're gonna have events? Like some ads, or someone told you? Someone told you? Good. All right. So we stopped paying for ads. Okay. Cool. something that I want to share with you, that's our meetup discount code for KubeCon in Paris next year. I will hold that for a sec. I'll post that in the CNCF Slack, their Bulgarian group, so you can check it there, and we'll send it somewhere, some other way. Something that I want to share with you is FOSDEM coming up next year on the first weekend of February. The CFP is still open if you want to talk at FOSDEM. You can apply there more than 30 forums. It's crazy. If you haven't been to FOSDEM, you'll be surprised at the conference. And if you want to just attend and listen to some stuff, it's crazy, and they have great beer, and you can drink beer at the conference. So it's perfect. Next one. We're going to skip December. It's going to be hectic, and people are traveling around. So next one will be, it will be January 25th in the Zuzu office. I see the people nodding. Maybe that's new for you. I don't know. Okay.
Everyone.
Yeah. So January 25th, we'll be in the Zuzu office. So today we have two talks. The first one will be by Yogi and Rado about secrets and speak and inspire, and the next one will be from Bazu about the SAP architecture overview thing, which is just like super complicated. But you tell about that. So how to stay in touch with us? We're primarily on meetup.com. Our chapter, if someone was so good to sign up for the community chapter at CNCF was closed, so you can use it. So the other way to contact us is through the CNCF Slack, the Bulgaria channel, and we have Facebook. I don't know. And the last thing is, if you want to talk at our meetup, that would be great. So you can scan the QR code that will open up a Google form for you, so you can fill in. It's super simple, and we'll contact you for the next editions of the meetup. With that, thank you very much. And two housekeeping topics. First of all, the restaurants are just around the corner, and to request this pass, to inform you that you have to push the doors, not to pull them. And second thing, he spent like 5 minutes trying to get in. Second thing, if you have a car, don't forget to take your car out, otherwise you'll be locked and you not have a car anymore. So count your drinks and take the car out on the way out. So Nikki, I'm sorry. So that's the housekeeping rules. We left some stickers from KubeCon on the area where the pizza will be later on, and some other goodies. So feel free. Please don't make a mess. If you want something, take it, but don't make a mess with the stickers. It will be very appreciated. With that, you're folks. Thank you very much.
So, hello everyone and welcome. Today with Rado, we'll try to show you how you can get rid of your application secrets so you can be proud in front of friends and family. We will use the following agenda to meet our goal. We'll first start by defining the problem. Then we'll go over a plausible solution in the face of Speak and Inspire. And last but not least, we'll finish with some practical use cases. And if the time allows, we'll take some questions live. Okay, let's get going. And for the purposes of that, I'll travel a little bit back in time, something like 15 years when I started my career in IT. Back in the days, we used to have a few machines under our responsibilities. They were named with human-friendly names. We were taking care of them. We were installing new software. They were safely communicating with each other in plain text without any sort of passwords or keys or anything else. We exposed just a few ports to the outside world and everything was fine. At the end of the day, those machines were located just behind my back, just behind my desk, and we were physically, basically, securing them and taking care of them. Nowadays, the situation has changed a little bit. Now those boxes have grown, the lines between them become a little bit more and also a little bit more messy. We can't ensure the same physical security that we used to do before. We can't draw these lines around the machines anymore. And the most typical solution, which will be our problem, to ensure the security and to ensure all our boxes are communicating in a secure way are the so-called secrets. That's any form of APIs, username, passwords, certificates, any sort of sensitive data that we basically ensure plays in one process or one application and then use it to authenticate to another application. Those secrets, while they are the solution that you can see today, they are not a silver bullet and they are not a free lunch. Basically, every time our application needs a secret because it's something sensitive, something that we need to protect, because if someone steals it, then they steal our customer data, they steal our identity. Every time we need to protect those secrets, we usually come with some sort of encryption to be able to encrypt the secret, so we safeguard it against malicious users. And that happens with some form of decryption key. This decryption key on its own, in an abstract way, can be seen as another secret that we invented to be able to protect the first secret that we started. So what do we do with it? Well, we store it in a secure place, something like the HashiCorp vault or any sort of secrets repository that is available out there. However, in order for us to be able to read the decryption or to open the secrets repository, to be able to read the decryption key, we need yet another secret to be able to open that. And I think most of you already follow the recursion that we invent secrets to be able to protect the very first secret. So we are sure that the thing that our application is able to authenticate with it in a safe manner. Okay, and even when we find this precious secret zero and we store it securely, we identify it, this is again not a free lunch. Every time we need to rotate that, we need to be cautious because we don't want to cause downtime. In addition to that, we don't want it to end up in the wrong hands, leaking somewhere in logs, in backups, or any other place that it is not intended to be, GitHub repository, for example, or anything else. So we basically introduce more and more challenges, and we follow kind of this rabbit hole of introducing more responsibilities on ourselves. And even when we decide, okay, I'll use my favorite container orchestration platform, which used to be, or which is Kubernetes. And when I decide to place my secret in the resource that is called secret in Kubernetes, that doesn't actually mean that this will be treated as a sensitive data, and it won't be yet another byte array that is just stored somewhere on the file system. It's encrypted in transit, and sometimes it's protected. Okay, now defining this problem, let's see how can we do better. Well, let me introduce you SPIFFE and Spire. Those are two projects coming from the CNCF Foundation, which aim to solve exactly this challenge and exactly this problem of secrets all the way down. SPIFFE is the specification, basically a set of APIs and docs, and Spire is the reference implementation, which is trying to put a running system and software based on those specifications and based on those concepts. Now I will go over a little bit more of the theory behind SPIFFE and Spire, so we can follow then the use cases and the examples that Rado is going to give us. Okay, so if I have to use one sentence to describe SPIFFE, that would be basically it's a spec defining short-lived cryptographic identity documents. Those are called SVIDs, and that's done by a simple API. Okay, let's try to depict that sentence phrase by phrase and give you some examples so you can understand what SPIFFE means or what SPIFFE is in more details. We'll start with the first keyword, which is the identity document, and this in the real world, in the physical one, you can see it as an abstraction of our passport or our ID card. Basically, SPIFFY tries to introduce the concept of digital identities for the software and applications and the processes that we have. That's in the SPIFFY terminology, it's called SVID or SPIFFY Verifiable Identity Document. SPIFFY does not try to reinvent the wheel. It tries to use as a foundation, use as a base layer already established standards like JOT tokens, like X509 certificates, and tries to put higher level abstractions which are simple to use and can be followed and can be used to simplify and group the domain concepts. Like here on the right hand side, you can see an example of a X509 certificate. Here, this thing is the validity of certificate, which is 7 days, which is considered to be a relatively short-lived certificates. And the thing that you see here at the bottom, that is the so-called SPIFFY ID, which is another term and concept of SPIFFY. And that's a unique identifier that basically you can use later to correlate who is the owner or put some semantics into it. So then you know what is this system or what is this workload or what is this process that actually owns this certificate. Okay, and last but not least, the last part of the single sentence definition. This is the simple API, which in SPIFFY terms it's called the workload API. It has one main purpose: to introduce this precious credential 0. That's done without the need of pre-shared username, password, or any other credential to be able to break this vicious cycle. And also, in addition to that, it offers some features like streaming updates or streaming some changes to the identity in case the process needs to be up to date whenever something changes there. Okay, now having the SPIFFY out of the way with the basics, let's go over Spire, which is the reference implementation. It's the software that tries to put those specifications in practice. There we will start a journey from the perspective of the workload, which can be any sort of software application, service, business application, anything that we write. So this is basically any box in this initial picture that you saw that actually needs some form of identity, needs some form of authentication. This workloads communicates with the first component of Spire, which is the so-called Spire agent. The Spire agent has also mainly one purpose: to serve the workload API and give our workload its identity document. The Spire agent doesn't do that alone. It also communicates with the second component of Spire, that is the Spire server. So relatively classical kind of architectural pattern. You have an agent, you have a server. The server is key component of the whole system. It owns the keys that are able to sign those cryptographically verifiable documents. So it's considered a fundamental and instrumental part of your security. Okay, and if we try to put those things, those systems into something like Kubernetes, usually our workloads run as pods. The Spire agent run as a daemon set, basically on every single node and VM of our cluster, and the Spire server can run in the same or in a different cluster. Okay, we saw a bunch of boxes and lines, but we didn't actually see how this magic happens, how this secret can disappear. Where for us to be able to understand that, we'll need one last term from SPIFFY and Spire, and that is the so-called attestation. That's the work, that's the process that makes this whole thing work. And here we have our main actors, the agent and the server, and then another important aspect of here is we need to root our trust into something. In this example, we chose a popular infrastructure provider, GCP, and the very first thing that, for example, an agent running in a given VM provided by GCP does, when it starts, the first operation that it does, it communicates with the internal GCP APIs to obtain an instance identity token, as it's called from GCP. And this is a unique token signed by the GCP keys and uniquely identify every single VM that they provision. Then the agent sends that token over a TOS connection to the server, and the server then has the job to verify that it doesn't blindly trust. It verifies that this token is indeed signed by the GCP keys. In addition to that, it can do introspection of certain attributes, like what is the project where this VM is running, what are the security groups, what's the service account, what are some additional labels. Any sort of metadata that we care can be checked from the Spire server, and only when all conditions match, then on step number 4, our agent will take this precious identity document, and then it can start using it. So basically, again, if we draw the parallel with the real world, our agent acts as some sort of a agent and asks control questions to the workload and verifies that by some sort of trusted authority. And only when all questions get the right answer, then we give our workload their passport, and then it can be used to further present itself to the rest of the system that it needs to communicate. Okay, so far so good. We introduced the VM, we introduced the box, we introduced the agent. How about the process running on that agent? Well, if you follow so far the process, you see the pattern here. Basically, we can repeat the same thing all over again, but within the context of a given VM or a node, where things start with the workload, which is a process running in a given virtual machine. The workload starts and say, hey, agent, give me my identity document. The agent doesn't blindly trust, it can verify. For example, if you're using Kubernetes, it will verify with the kubelet. Okay, this is indeed a container or a pod running in a given namespace with a given service account, with a given image, with given labels, any other attributes or selectors that we want to verify. And when this verification passes, then we get our precious certificate. In this case, can be a job token as well, and our workload can start using that to authenticate itself. Same thing can be applied with the Unix kernel or the Docker daemon. Spire has plugins for those two. Okay, and without more theory, I will hand over to Rado, who will give you some practical examples of how these concepts work in the real world.
Thank you, Georgi. Working. So, so let's talk a little bit about a very pedestrian use case, something that you're all familiar with. My name is Greg, so I call them service B and service A. So basically, what we have here is something that everyone has in a certain form, a service that is consumed by an application, regardless of where they live. We have picked Kubernetes and Cloud Foundry, and the communication between them is secured with mutual TLS. So, you know, very familiar stuff. You know the drill, how to generate the certificates which are used to configure the connection. You basically need to create private keys. You go through a certificate signing request. You have the certificate authority, and eventually you end up with a certificate that you need to deal with. Nothing complex. Basically, everyone can do it, but usually when the scale gets bigger, things start to get complicated. And for environment like SAP, for example, I guess a bigger company, people start to involve different teams, processes start to be built, who generates the certificates, who deals with the certificates authority, what kind of precautions we are going to take, how we are going to rotate certificates, and so on. So basically, things get complicated very fast. And ultimately, we end up with something like this. Here, we have basically oversimplified a setup, but ultimately we end up with two parties where usually they don't talk much to each other, but they need to provision the certificate that they got. Either through some kind of a CI system like Jenkins, they have automated, maybe they have put them in Vault or something like that, or they do it the usual manner. They have implemented a few bash scripts and they have put it somewhere to provision. But basically the certificates are more or less provisioned over like a configuration with the life cycle of the application. So ultimately, this brings us to a setup where certificates usually have months and or years of validity, and we kind of try to avoid certificate rotation at all cost. Although the security says that we need to to do it regularly, and I'm pretty sure everyone at certain point in time had a hiccup with that. We did have one lately. So how does Speak Inspire solve the issue? Here is where I tell you it's really simple with Speak Inspire. You put some magic inside your cluster and everything works. Unfortunately, I'll be lying. I mean, there is a lot of complexity. It's shifted, but it is there. But you need to know what you get in this case. For example, Spire server will do the attestation. So basically, your applications will get the certificates in runtime. So no more processes where human needs to do anything. You don't need to configure the services. They're totally separated, so no need of some kind of human interaction or integration in the processes. So what you can also is Spire will do the rotation for you. And basically, the time that the life of a certificate now has become very simple configuration that you need to pick based on your security preferences. And it's no longer a question of having them for like 90 days or 60 days. You can do it even for 6-7 days or even lower. How does the adoption happen? Actually, Jerome mentioned the Spire agent provides a very simple API. Here we have a few options. For example, if the application is some kind of legacy application that you don't really have the time to modify or don't want to modify, you can put something like Envoy in front. It integrates well with proxies, also with Istio. So basically, the component can do determination and origination of the mutual TLS. Basically, that both services don't need to know that they are communicating over mutual TLS. So basically, that's a very simple way to adopt the service. Or you have a more advanced setup. You can basically modify your code and directly interact with the agent over the simplified API, which is basically gRPC API, which is not a big deal to handle. But there are options based on exactly your needs. We have tried a few of them. They can actually work and are usable. We have talked quite a lot about Speak Inspire and a lot of technologies and a few things like attestation and NSWITs and so on. But basically, there are a few things that we would like to convey as takeaways and for you to take from this talk. It's basically that security indeed is a journey. You will move to different stages in this journey, and we hope that you consider Speak Inspire for the next phase in yours. We would suggest not to reinvent the wheel. There's a lot of software, there are standards, tools, and processes that are basically out there right now, and you can leverage. And if you do the previous two, then you don't need to sacrifice the innovation speed of your project. You'll end up with a secure enough environment, and you will do less stuff. It will be complex again, but at least you will have fewer things to deal with. So with that, I'd like to thank you for your attention. If you have questions, I'm not sure if we have time for questions. Yeah.
Yeah. Anyone questions?
Hello, thank you very much for the great presentation. My question is, does that station in the Spire server already have some implementation for working with non-cloud provider workloads?
I'm not sure, actually. I mean,
yeah, so they get this loadable architecture. So basically, you can plug your own thing. They also have plugins to work with hardware modules, these TPM modules, so you can work with the bare metal. They tried to make this open source project quite extensible, and you can plug your thing in there. They work with the popular cloud providers. They work with Kubernetes. So yeah.
Yeah, basically AWS, GCP,
Yeah,
Azure, all of
those
you can-
are supported, and they come with the plugins from the community, but you can also provide your own plugin, and that's how most of the people use that.
Thank you very much. And I have a second question, if that's okay. In your experience, what is better with SPIFFE and Spire compared to cloud-specific implementations? Like, for example, AWS has like AIM roles for service accounts and stuff like that.
Well, the cloud services actually work great if you're confined into a single cloud provider like AWS, GCP, and so on. There, it's almost unbeatable, to be honest. But when you have to move in the picture that you're showed, you have few of them, then you'll definitely feel the good part about SPIFFE and Spire.
Anyone? We have time for one more question.
One behind you.
Oh, sorry.
How does Spire agent work with serverless?
A great question. Push. So instead of the agent having to run as a process next to it, the agent can push. For example, if you use Lambda, it can push to an AWS secret, and then it takes care to rotate that, but it should run somewhere independently from the workload, because I mean, with Lambdas doesn't work this attestation process. So that's how it works. So SPIFFE and Spark has guides, has ways to handle those environments who are actually more on demand quickly.
All right, let's give a pause. If you have some more questions about SPIFFE and Spire, you can ask who from the pizza later on. And now Vasil is going to talk about the adoption of Kubernetes itself, right?
Yeah.
Yeah, that's.
Can you hear me? One sec. I do have to share my screen, right?
Yes.
There's some tool.
Yes.
It's working.
Yes.
Okay. Well, welcome everyone. Yeah, my name is Vasu, and as you can see here, I'm one of the chief architects at SAP. But indeed, I deal with the core of cloud native aspects at SAP, and I currently also hold the governing board seat at the CNCF. And my talk for you today is actually, if you kind of look into it, you will also learn why SAP actually joined the CNCF, right? And yeah, it states how we injected the Kubernetes virus into our corporation without activating the immune system. And that emoji at the end is a tongue-in-cheek emoji, right? And it's actually an excerpt of a longer talk, and it is more about strategy, Conway's law in a large corporation, and a little bit of architecture and design pattern. And I don't have a concrete Kubernetes demo, but I hope you can take something away from it. I had to fit the longer talk into a 45-minute slot, and it's still a packed agenda, and I hope it's not too bumpy because I have to jump a little bit of things. So let's dive in. So as you noted from the title, yeah, the pun, it insinuates a humorous narrative, right? That kind of distributed systems are like Kubernetes is something completely new in the world of SAP's monolithic architecture.
and that there's a corporate immune system that fights against innovation, kind of like in that picture that I posted here. But then you have to ask yourself, right? SAP is one of the most successful business software company out there, and what technology has made it so incredibly successful? And I assume that not many of you here, some of you are of course with SAP, but not many of you know about the SAP's classic technology stack that made it so successful. And there are some crucial lessons from that which we need to extract. So bear with me, I need to take you into a short intro into the classical R3 in architecture. So very easy, I think you've seen this, this is the real-time version 3, R3 version, R3. Before that there was R2, and it was on 06/07/1992. SAP switched basically from the mainframe to this 3-tier client-server architecture called the ABAP platform. And first of all, you might wonder about that precise date. If you ever install an ABAP system fresh from the ground, that's the default password, right? That's the date. There's nothing new here for you today, but back then, SAP was the first mover on this technology, right? And it was the first one who used that architecture in a major product, right? And the stack, interestingly, was available or was made available on almost all types of architectures like x86. It was available on all Unix's operating systems, Linux, of course, and Windows, AS400, and it worked with all types of enterprise databases. So the ecosystem was very important because every dollar spent on SAP software, promoted also partners' economy, right? And we had Vora, write once, run anywhere functionality long before Java made it popular, right? So you could actually write something on, let's say, Unix and move it to Windows. Worked just like that, right? And you could switch out the database if you wanted, right? And one more astonishing thing, and also should connect with you, SAP shares the source code with customers. There's full transparency. So if you think about this, SAP fulfilled 3 of 4 criteria of free software, not the economic freedom, it was still commercial, you had to pay for it, but all of the rest you could see, deep dive into the code and so on. It was not open source. And I would argue that this was a novum back then and was a considerable part of the success DNA, right? But the main reason why I wanted to tell you about the ABAP platform and how its value proposition adjusted itself into partner environments is this here. Remember the colors, remember this graphical representation, we will be returning to it again. So if you agree that an operating system is the body of the software that abstracts the hardware platform, protects software principles from each other, you heard just now with SPIFFE Inspire that is one type of a software principle, secret though, and it multiplexes machines' hardware resources, then the ABAP platform monolith is basically an operating system in its own right. It's adjusted on to foreign environments, and that means on the lower operating system. And that's crucial. We'll come back to it. So just the first conclusion here. So because of the viral nature, which I mentioned earlier in the title, the ABAP platform is core to the value stream. So the corporate immune system, whatever that is optimized to protect this value stream. So if you want to introduce Kubernetes or anything new into this corporation, you cannot do any, these fundamental changes that are completely new. You cannot do it without breaking. You can't break anything. Yeah. So no breaking changes. But alas, change is the law of life, and those who look only to the past or present are certain to miss the future. Nice quote from JFK. And you know, the change on the business perspective is that the commercial model is moving to the cloud with software as a service. I don't need to tell you this. It's even like people don't care, consumers don't care how that product is or the software as a service is produced. The customer only gets an API contract to the application and maybe its data, and the customer does not need to know how it's built. It's implementation detail. So let's take a look at how can we go with our core product, like the ABAP, the ERP, which is built on ABAP. We could do that in the first step by just moving the technology stack, keep it as is, and for every tenant that we onboard, we just spin up a new platform tenant, if you will. And you would be probably right in thinking that this is suboptimal, right? That this is what some would call cloud washing, right? And yeah, from a pure business perspective though, yeah, we would have to optimize the margin cost at some point. So that curve over there needs to flatten, right? Because, in the beginning, you might, for the initial setup, it might be more expensive because the opportunity cost is driving what you can charge for the next subscriber. You have to charge more. And at this point latest, your technology choice and your technology stack that you're using shines through because the subscription fee must be competitive, cost of operation is tied to the technology stack, and the software as a service run on a technology stack that is designed for cloud is more competitive. And the cloud sprouts competition. So that's one of the key arguments here. And I have not been completely truthful. SAP did not only have ABAP, it acquired a lot of companies, and these acquired companies brought with them their own technology stacks. Yeah, and some of them were also born in the cloud with a software as a service model like SAP Concur. So this is a classical innovator's dilemma. And we were thinking, is there a possible common denominator? Now, I know you know the answer already, but let me guide you through our thinking back then. Because clouds and competitive modern SaaS are inherently powered by distributed systems. Yeah, and like Kubernetes more or less, but let's not get too fast ahead of ourselves. Our idea back then, remember, this was actually also before Kubernetes started, was inspired what we knew from how today's hyperscalers run. So Google, for example, had Borg. The other hyperscalers have different systems, but they're all distributed systems, right? And the hyperscalers build a distributed system on top of a warehouse scale computer, and from which they can actually build all the X as a service. And remember now the picture with the ABAP platform. It was designed as an operating system to fit into other operating systems. So our idea was, why not build our distributed operating system on top of different ones using infrastructure as service now, and only the commodity part, and present a working abstraction for our software. Now, the abstraction here does not need to be as tight as with ABAP. It has to be open. So, but before we jump to conclusion with Kubernetes, let's take a look at all the requirements that were haunting us for our decision purpose. So, first of all, similar to ABAP partnering with operating system vendors and hardware vendors, we needed to be able to partner and co-innovate with the cloud providers. So we're not competing with the cloud providers first. And then secondly, the blue layer, our distributed operating system, should just provide enough abstraction so that we do not get locked in, yeah, for the commodity type of things. Yeah, so obviously if there's a special service underneath, we should be able to use it, like AI and so on. And the blue layer, and this is very important, must be acceptable by our partners, our acquisitions, and all existing lines of businesses that already we have acquired, yeah, because we would now be asking them to build or port their software on top of it, yeah, and ideally it should be an accepted standard. And yeah, how do we bring that, and to answer the question, how we make that change? Well, without disruption, we slip it underneath as an underlay, and the product teams need to adopt it themselves. That's how we did it. And now the question, how do we get started? Well, of course, we did it with Kubernetes because it's open source, it's neutral, it's neutrally governed, it's viral because people read about it, and it is because we can slip it underneath, it's non-disruptive. People can take their own path and choose their own path. Well, and thus, that is the reason, more or less, we started Project Gardener, right? So we'll talk about this a little bit, later. Well, why the name Gardener? Well, we use botanical terminology because right from the start, we knew that we needed many clusters, and we wanted to create delightful landscapes, if you will. Yeah. Okay, and on a higher level, I think, again, you see, I love these colors here, right? Think about it when in the 1940s, when the first computers were designed, the von Neumann architectures, software and hardware were built together. It took something like an operating system as an intermediary between the hardware to disconnect it, disconnect your software from the hardware directly, right? And I think, this is exactly what's happening right now in the area of the cloud. Currently, X as a service is directly bound to a cloud provider. It locks you in, and an open distributed operating system out of the CNCF is exactly what people want. Yeah, that's the affinity of Kubernetes, if you will. All right, so now I had to skip a number of other cloud transformations so I can open source and OSPO topics, which are important for corporate engineering, if you will, because I had to fit it into this timeline. And back to the technology disruption front. How does it affect business? So now the Gartner analyst, Gartner with the T, proclaims, and I submitted a great deal of truth to this statement, that more than 85% of organizations will embrace a cloud-first principle by 2025, not too far away, and will not be able to execute on their digital strategies without the use of cloud-native architectures and technologies. This applies to almost all companies out there because all companies are becoming digital, right? So for us, from a architecture perspective, SAP now has this nice picture here. The business technology platform drives all of the commercial products, and the business technology platform is now going to be driven cloud first and cloud native, with cloud native. But we had to start somewhere, as mentioned, and the Gartner was our tool. And what we did is, this is the Gartner mission statement, we basically produced a kit for universal Kubernetes at scale. So this statement has a lot of, it's loaded. Universal means homogeneous, multi-cloud, and so on. At scale means thousands of clusters, speed management, and so on. And if you look at this slide here, Gartner today is available under Gartner.cloud. And you can see how it's already part of the distributed operating system and abstraction story. And I will skip a little bit less. It works on all these different cloud infrastructures and so on. And I will not today start explaining specifically how Gartner works. It could go into this direction, but I will not. I will instead ask a different, more important question. And with that, you will understand actually Gartner indirectly as well. So the question I'm going to ask is, how does, if I get something like Gartner or cluster API, or I can create Kubernetes clusters all over the world, how does it help me to create a globally distributed software as a service product? So basically I have a commercial product that I want to deliver globally as SaaS. So I don't actually care if it's Gartner or the other symbol there is Cluster API. Any type of Kubernetes managed thing should work. That's my challenge. I have my application and I want to deploy it all over the world. And I want to manage it globally from a single vantage point, if you will. So in order for that, I need to do one small diversion because I need to get to 4 points. So we'll say Kubernetes controllers in action. Yeah. So in this scenario, I want to explain is essentially I want a payload to be exposed to the end user in the real world with an ingress and a service and so on. So in order to get to that payload, I have a deployment. Nothing fancy, you know all about it. If you have played with Kubernetes, you should know about it. So let's take a look at what else is needed. So first of all, the payload doesn't get instantiated as a container from itself. You need a pod. For the pod, you need a scheduler and a node object. The node object is controlled by the kubelet, and only then the payload gets instantiated. But that's not all. The pod, you typically don't deploy a pod, and we didn't. We did deploy a deployment. Yeah. You need a replica controller set. The replica set comes via deployment controller. So now you got that payload running, right? So it's a abstraction above abstraction and so on, and everything is kind of interactive. On the networking side, you need a kube proxy. The kube proxy needs an endpoint controller, right? And then you need for the ingress, for the service to actually get traffic coming in, because that first service is just an internal service. You need an ingress controller and another service. Again, then that service has a load balancer, and the cloud controller manager creates an IP address for you, and so on. And if you want to also automate the DNS entry and so on, you need an ingress DNS controller and so on. So there's a lot of, this is a convoluted map, but I wanted to show you this because I wanted to remind you on 4 lessons. First of all, would a waterfall architecture council approve something like this? So it's a rhetorical question. I would argue no. Yeah. The second thing is that what you saw here, the architecture of Kubernetes is more a control through choreography, or what I also like to call, like, it's comparable to Adam Smith's invisible hand from the economic. So every controller is very egoistic. It just cares about all its own things. Yeah, it wants to, each controller has its own objective. It doesn't care about the greater good. But overall, this thing, and if you have honest participants in there, you can't have a controller which deletes like Chaos Monkey or something like that. This architecture is extremely robust. And the 4th lesson is the following, because I would like you to focus only on these, on the schema here with pod node and so on, because there is a hidden pattern in front of your eyes for actually scalable, global scalable services, right? And the Gartner folks don't say anything, and the ex-Gartner folks also not. Yeah. So scalable service management with this pattern. So let's adapt our objective or challenge to, we're going to use only Kubernetes principles here, right? This design pattern. So the first thing what you're going to do is you're going to say, all right, I have a payload cluster up there, yeah, and I have my management cluster. In the management cluster, I just said it's a dashboard, right? It could be a different API, yeah, but the dashboard where the user kind of clicks and it says, I would like to have an instance or 2. Yeah, the user orders instances. So what the first thing what we do is we model the requirement into a CRD, a digital twin, if you will. Yeah. So what happens is via the dashboard, you order a service instance, and what happens is the dashboard component creates a CRD request, a custom resource request of that service. You have to model it, obviously, and it lays it into that middle piece. In this picture here, by the way, we've separated, it's not all in one cluster. So we have one management cluster, it's by the way, one management cluster and one cluster where we put the digital twin objects in. Yeah, and then the payload cluster. So it's three Kubernetes, if you will. So obviously then somebody's got to do the work. And that's typically the instance controller. Yeah, so you put or some type of controller, because we're in the Kubernetes space, which does read, oh, there's a new service request or service instance request, and I do the work. I create that instance, whatever belongs to it in that payload cluster. Okay. And then let me skip that. Then the question is, what happens, in my challenge, I already told you that I wanted to go global. So one payload cluster doesn't do it. So you have to have multiple clusters. Yeah. And there are many reasons for that. My reason was multi-region. Yeah. But you might have security requirements, customer separation, maybe the payload cluster, the size is not enough. Yeah, you can't grow it large enough. Maybe after your payload cluster can do 4,000 nodes, but then you need a second one, and so there are enough reasons. So then the instance controller here needs to be able to work with 2 payload clusters, right? So what is the end size of this? This is how most of the projects start, by the way. Yeah. So how large can you size this thing? Can it do 2 clusters? I'm sure. Can it do 3, 4, 5, maybe 10? Can it do 1,000? Yeah. So what happens then? Because the instance controller has to reconcile. So you have, and people, when they start getting at the edges of scalability, they kind of say, okay, I don't need to reconcile every 30 seconds. 1 minute is enough. Or maybe half an hour is enough, right? Is 1 hour enough? Yeah, I don't think so. If something is wrong with that instance in Japan, and the Japanese customer has to wait until 1 hour until reconciliation happens. So what is the solution to that? So our solution is essentially to say, hey, we actually put the business logic of how an instance is created, we put that locally next to the payload cluster or to the payload environment. And we create a new digital twin object called the runtime. That runtime object is serviced by the servicelet and offers the scheduler, which is central, to make scheduling decisions. So when a new service instance is basically placed into in the data plane, if you will, the scheduler says you will run in the northern cluster, the north cluster here, and then the servicelet picks it up. Do you recognize this pattern? I think you do, yeah? So, and then if you want to expand autoscale, you can actually also say, have a runtime manager, which looks at the runtime objects and says, oh, my Kubernetes payload clusters are all full. I need a new one. You can actually order a new cluster. Now, we do it with the Gardener. You could also use cluster API. It doesn't matter, right? So now do you recognize the pattern? I don't see a lot of nodding heads. Who recognizes the pattern? Hands up. Okay, so then let me make it clear. It's the kubelet pattern. So the one why I showed you the Kubernetes controllers in action, it's actually exactly that, where the Kubernetes cluster here, you can see the kubelet in locally on every node, yeah, and the scheduler, and well, if you want to automatically expand the Kubernetes cluster, you typically have something like the cluster autoscaler and the machine controller manager or something in between. So now you can see it's the same thing, yeah, for service management. And the interesting thing is people say to me, the kubelet pattern is a local thing, right? It doesn't spread globally across the world. That doesn't work. So you are telling me, Vasu, that the service management, like this here, the servicelets, one servicelet is in Japan, the other one in North America, and so on. And does this work? Right? And they're skeptical. The interesting thing is, I just told you how the Gardener works. This is the Gardener architecture. It's the same thing. Same thing. It just has the gardenlet, and the management objectives are a little bit different. So we don't have the runtime objective. We have a seed. That's the place where control planes are being hosted. And we call the clusters that we order, we call them shoot, again, botanical naming. And we have an automatic garden autoscaler that if we don't have any more seeds where to put the control plane in, we create them again automatically with the managed seed controller. So the autoscaling part is in there, right? The interesting part is, which I as an architect find beautiful, is this architecture with the gardenlet has an interesting closure. Whereas, the kubelet kind of deals with pods. It's also beautiful because containers run, Kubernetes is run via pods itself, right? But the gardenlet and the Gardener architecture is special because it has a closure. We actually manage Kubernetes using Kubernetes itself, and it's the kube inception program. And you can actually go beyond. The service management also works for, let's say, multi-tenancy. So if you want to have a service tenant, so if one instance can do multiple tenants, you can actually do a tenant scheduler, devise a digital twin object for that and model it accordingly, and you can have an instance manager for the tenant on top. So this is abstraction-wise, we can actually always put another level of abstraction on top, right? And yeah, so coming to the conclusion, I hope you got it. I don't know. This is essentially how we do it at SAP, yeah? And because when I was discussing even with some people earlier today, they were asking, how does it resonate with, cluster API and so on? And this is my take. When we designed Gardener, we kind of started with a top-down approach. We didn't think about how do we bootstrap this thing. Yeah, we said, imagine we have already a distributed system based on Kubernetes worldwide, kind of symbolize it over here, and I have already a Kubernetes API. So I already have a place where I can put my control planes, right? And if you model things top down, you get a Gardener API. You get all of a sudden this thinking of autoscaling. You saw it how I explained it in the gardenlet thingy. We can think about creating another seed cluster, and then we can think about, oh, I have a control plane in North America. That control plane I want to push to South America. We can do that. Yeah. We have the localized business logic, obviously, in the gardenlet, and we have Gardener extensions for GCP, for AWS and OpenStack and so on. And the way we produce the Kubernetes clusters, they're homogeneous in nature for us, right? Because they're all built the same way intrinsically, because yeah, that's how the Gardener is designed. And because of the fleet management, we have a platform style of rollout of policies and configs and all available options. So if we, for example, use Gardener and we want to make a new operating system available, we logically make it available across all the regions and areas and so on. So it's a different type of unified thinking, if you will. And if you come, and this is not wrong, we never solved in Gardener, or not solved, we never cracked the question of how do we bootstrap this thing. So if the VMware folks started with Cluster API, and very nice, they tackled it from bottom up. So they're thinking everything is a machine. So what you need there is you kind of also need a kubeadm or kind cluster in the beginning. And then you come up with a cluster API, right? And then with cluster API providers and so on. But the platform thinking comes after that. So that's not part of the cluster API per se, right? The way you use it is a different, and how you embed it in your platform. That's where the platform level thinking comes in. So yeah, the cluster API can go up and we can go down. So this, in the middle though, interestingly, we both invented the same things, namely the machine controllers, the machine class, and machine deployments. We all have the same technology here. Yeah, and yeah, we are collaborating there as well. So in the end, I would say, you know, if you come from bottom up, it's very attractive for individual developers because they can use it directly on their laptop, right? And start experimenting with that. And then it gets adopted by service teams because, you know, they know how cluster API works. And this is unfortunately for the Gartner folks, the, let's say, energy barrier. Our product, or let's say open source project, is attractive for service teams and enterprises first and foremost, not for individual developers. Because if you only want your cluster API or cluster working on your laptop, and maybe on 1, 2 of them on, let's say, your Hetzner or AWS, then you don't start with Gartner. It only makes sense if you have to deal with hundreds of clusters. And you will see that in the next question I'm going to answer is, have you been successful? So first of all, at SAP, Gartner is powering the BTP, our commercial entity here. Yeah, it's the Gartner is not available for customers directly, only indirectly with a product that uses it, like Klima and so on. That's the natural direct where you can get Gartner clusters directly for use. But interestingly, ABAP Cloud, if you order a commercial ABAP Cloud instance, is powered on Gartner. So the ABAP stack, they have taken things apart, they containerized all the individual bits and pieces, and now they can chip carefully and optimize and make, you know, remember the cloud washing question, yeah? They can actually make ABAP truly cloud native. Yeah? Some things will not go away, it will take a longer time, but they can optimize. And you know what the project, by the way, is called internally? It's very funny, it's called steampunk. And steampunk is kind of, you know, the notion of taking old steam engines and creating these airships with it. And I also have a Kelsey Hightower screenshot here. So 2017, he predicted that monolithic application will be back in style. Yeah, and 2023 reality. And that's exactly what happened with the ABAP context. But it's not only ABAP, by the way, even stateful, you know, remember all these discussions about stateful, should you put stateful applications into Kubernetes? HANA Cloud, I mean, I would argue for, you know, the most difficult database system. It's an in-memory database system. It's got to give you systems of records guarantees. It runs on Gartner. Yeah. We also have been successful, I would argue, in the outside world. So this is the Lidl Schwarz Group. You know, Lidl, I think it's also here in Bulgaria. They run Stackit, their own enterprise IT or cloud IT, if you will. They're running Gartner. They're actually adopters of Gartner. We've got a sovereign cloud startup called MetalStack. They actually run Kubernetes clusters only on bare metal systems. We collaborated with them. They use Gartner. There's a Swedish company doing sovereign clouds. They run Gartner. And there are some startups running Gartner, 23 technologies here. We also have some small software companies, software startups, which don't deal with Kubernetes at all, but deliver something else, namely in this case, CodeSphere. And they're actually told us we're using Gartner because it's much cheaper for us on scale. We need to run on Equinix, OpenStack, and Google, and it's much cheaper for us. to run it. And yeah, interesting. And this is a small startup, and this is China scale. So I don't know, TIDB, also CNCF project. It's a database from PingCap. It's a managed database offering. They're using Gartner underneath. Anyway, that's my talk for you today. I don't know how are we on time. Should I give a small demo, or is that possible? Yeah, okay. Then let me actually see if I'm still online.
It's no like 5 minutes, right?
Yeah, 5 minutes, a small demo. So if you log on to Gartner, this is also the UI that is part of the open source project. Yeah. And I just logged in. You can actually see I've started a small project. Well, actually, I'm in one project here, and you can see most of the development. This is our open source development environment. Yeah, most of the clusters are actually hibernated. So one of the features that actually really saves us a lot of money. And here you can see this is actually a cluster which I ordered for the demo. The API, it's a YAML file here, it's Kubernetes style. You can see this was generated actually. Oh yeah, and before the interaction to create new clusters is just you select one of your favorite infrastructures. The on-metal project is actually another one out of the Gartner family where we're going down to the bare metal as well. You can choose the region. You can see all the regions are where we are supported. You can choose the networking overlay type. You can choose control plane high availability. We have even special things for EU access and so on. So regulatory stuff. You can do Garden Linux. So out of our environment, we also created our own Linux derivation, if you will. And also SUSE host and so on. And yeah, we automatically update. This is like fleet control for you. And if you don't do anything, we hibernate the cluster if you go home, right? So that's just kind of a look and feel. But what I actually wanted to show you was this. So I can go in and open one terminal to the Garden cluster. So the Gartner, the central Gartner is running there. I will in parallel open another to the control plane. And I will split again and open a one directly to the cluster, one terminal. So up here, I'm in the Garden cluster. Here, I cannot do get pods and so on. It's not available, but I can do get shoots. And here you can see all of these shoots or clusters that are in my core project. Yeah, I don't have access to anything else. And somewhere should be a demo too. There is my cluster here. See, yesterday I created it. On the control plane side, that is where the control plane is hosted. I was allocated automatically to an available seed cluster. If I do get pods here, you can see this is the control plane element. So there's etcd, you can see CSI controllers, you can see all types of additional things where there's the API server and so on. So that's in a different security domain. And then on this is my pod, my cluster itself. There you can see what has to run as intrinsic entity for Kubernetes cluster in your cluster itself. And everything here is automatically managed for you by the Garden Bed. So if I kill something here, it'll come up again from outside, from the Garden Bed. That's where the business logic is. All right. And with that, I think I've given you a good demo, hopefully. And I'm going to close with a ChatGPT answer here. Thank you.
Thank you. I'm sure you're full of questions, so we have some time for questions. Anyone? No? Okay.
Hello, thanks for the great presentation, it was fantastic. So my question would be, how do you deal with traffic, right? I mean, distributing code faults is fine, like, I mean, they're using the pattern, then how do you replicate the, load balancer, like on single cluster, how do you replicate global scheme?
On the global scale,
Do you play with DNSs, BGPs?
yes, it's so actually there's actually one guy in here, an ex-Gartner colleague, who actually implemented it. Yeah, so we have Istio in there, right? So we have to route traffic between. So first of all, from external, how do you get to the control plane, right? So we have an Istio endpoint in different areas. And then we essentially multiplex it to the control plane layers, and the control plane and the Kubernetes worker plane, they are connected through a VPN channel, right? And so because the control plane is residing somewhere else and is network-wise not in the same network as your nodes, right? So we need to also clarify that, and that's where we use a VPN. And there's bidirectional, there's complication there as well. But that's essentially what the Gartner project, I can only tell you, brings out of the box for you. Yeah. And it's a convoluted question. It's really difficult to answer in a 2 minutes. Yeah. But thank you for the questions. It's exactly the type of question you need to.
Anyone else? By the way, we have hats for the folks who ask questions. So can you raise your hands if you ask questions? Yeah, please. Yeah, no, no. Yeah, over there.
Since there's a local cloud solution, I was wondering, when developing the solution, did you work together with people from Microsoft, Google, AWS to come up with a solution, or is this all thought of in-house SAP? How does this work?
So interestingly, there was a lot of exchange where we started. I think there was the first KubeCon in Berlin when we started thinking about how do we bring this in. So the mission statement of Gartner. How do we create a service that is universal and global and so on? And there was a KubeCon in Berlin. I don't remember if it was 2015. I think it was 2015, the first KubeCon.
That's the second.
The second one.
The first one was in London.
Yeah. Something like one of the first ones. And there was a lot of exchange with startups, with smaller companies, and so on. And actually, we had an initiative going on to collaborate with Google. It fell apart. And again, and this is also maybe a strategic thing, right? Or a strategic question. Most of the companies where you can buy this kind of solution, they have a commercial interest in this. Right. We actually built this first of all, for our internal use case, and we open sourced it, and we wanted to also donate it to the CNCF community. We're still on path of it. We're still trying to, but the reason we don't have a commercial interest in this, right? Yeah. This is the setup at SAP. We more or less, and I wrote a blog, I think 2 years back or so for the birthday of Gartner. You can take a look at that, where we essentially argued that, by solving this problem for ourselves, we know a lot of our enterprise customers have a similar problem. And the Lidl-Schwarzgruppe, which I just mentioned, is a good example of how we can get into different types of conversations with our customers without having the commercials in the way, right? And during this process, so it didn't, as mentioned in the beginning, there was a lot of exchange with the open source community, but now there's actually a larger, let's say, enterprise community which uses Gartner, and we're actually we have been doing that quietly, the interaction and the exchange, right? And we do have a community, close-knit community, but we were not as open because people were afraid, hey, you know, in the recording I might have talked about, you know, our internal IT, and I don't want that to be in a YouTube video. So we do it first internally, close-knit, and then we cut it, and then we open it. So that's what's actually happening. And yeah, I hope this kind of answers the question. And now we're getting, let's say, contributions for enterprise questions like IPv6 and so on from other companies. So that's what's happening. Until now, we're not yet looking at commercializing this. So it's free to use, and you have a good, let's say, release train of coming upgrades and so on. Because as long as SAP is using it internally and it's still open source, it's, yeah.
Hi, also, and first of all, congratulations on the great work you've done with folks and on the presentation. And after this great presentation, I would ask what's on the roadmap for the government project in the near future.
Yeah. Okay, I didn't present that because it's not yet ready to talk about yet. But I can make an announcement because that has been publicized already. So you might have heard about in Europe, there's a so-called important project of common European interest. I don't know, hands up, have you heard about that? Yeah, so there are projects for battery research and so on. And there's one new project which was launched, or which is going to be finalized actually next month, hopefully. It's called the Cloud Infrastructure Services IPSI. Yeah, and SAP has applied for it, and we already got an early start grant notification, so where Gartner is already in, so you can read the press release on that. But the final notification is going to hopefully come next month. And Gartner is going to is one of our open source spillover bed for this IPSI project. So that is a big thing. And by the way, I internally have changed, and I'm basically, for that project, I'm going to be the chief product owner, more or less, right? You might have seen the announcement. Yeah.
Thank you. With that, we're gonna close for today. Another round of applause for Vasu. Someone made a terrible sound opening a beer right here, so let's have a beer and pizza. And don't forget, January 25th in the Suzuki office. Thank you.
Yeah.